Hello student, welcome and very good morning to you. Today I will be discussing the solution of IRODOV 21 to 24. This discussion will be extremely helpful for the preparation of NEET, main and advanced. I have already uploaded the IRODOV solution of question number 1 to 20. These videos are also be very helpful for you for the preparation of JEE Main and JEE Advanced. Please like, share and comment on the video because this comment will be extremely helpful to make the new video for you to get the best rank in JEE Main and JEE Advanced. Always connected with my channel. This question number 21. At the moment t equal to 0, a particle leaves origin and moves in the positive direction of x-axis. Its velocity varies with time as v equal to v naught 1 minus t by tau, where v naught is initial velocity vector whose modulus equal to 10 centimeter per second and tau equals to 5 seconds. Find x coordinate of the particle at the moment at t equal to 6, 10 and 20 seconds. Now look at this here, v equal to v dot into 1 minus t by tau. Now v equal to dx by dt. So dx by dt, this equal to v naught is equal to 10 centimeter per second and this is the 1 minus t by tau is the 5. So look at this here, dx by dt is the 10 minus 2t. So look at this here, dx equals to, this is the 10 minus 2t into dt. Now integrating. Look at this here, this is the dx from, this is the 0 to x equals to, this is the 10 into this is the dt, this is the 0 to t minus this is the 2 t dt, okay, t dt 0 to t. Therefore, look at this is the 10t minus this is the t square. This is equal to x. So this is the equation of displacement of the particle in time t. Now we have to calculate the x coordinate of the particle at t equal to 6 second, t equal to 10 second and t equals to 20 second. Now if you put t equal to 6 second, so you get 10 into this is the 6 minus 6 square. So look at this is the 60 minus 36. So this is the 24 centimeter. Now look at this x2. Now look at this 10 second. This is the 10 into 10 minus 10 square. So look at this is the 0. And x3, this equals to, this is the 10 into this is the 20 minus 20 square. 10 into 20, 200 and 20 square 400. So look at this is the minus 200 centimeter. No problem. Now next question. The moment of time when the particle is at the distance of 10 centimeter from the origin. Now look at this. Here x equals to 10 centimeter. So look at this here, 10 equal to, this is the, look at this is the 10t minus this is the t square. So look at this is the t square minus this is the 10t plus this is the 10, this equal to 0. Okay. So look at this is the t square minus 2 into 5 into t plus 5 square. So look at this is the 25 minus 10. So look at this is the t minus 5 whole square. This equal to 15. Therefore, look at this t minus 5. This equals to plus minus 15 root over. Okay. Therefore, t equals to, this is the plus minus almost 4. Therefore, t equals to at 1 second and 9 second, the particle is at a distance 10 centimeter from the origin. Okay. Question number C. The distance covered by the particle during the first 4 seconds and 8 seconds and draw the approximate plot ST graph. Okay. Now we have to calculate the time at which the velocity of the particle will be 0. Look at this. If we put v equal to 0 in this equation, we get, look at this, this is the 0. This equals to 10 minus 2t. Therefore, t equals to, this is the 5. So, at t equal to 5 second, the velocity of the particle is 0. Okay, so look at this. In first 4 seconds, the particle in moves in a straight line path. So distance is equal to displacement. So distance is equal to displacement. This equals to, this is the 10 into 4 minus, this is the 4 square. So 40 minus 16. So this is the 24 centimeter is the distance at t equal to 4 seconds. Now look at this. From t equal to 0 to t equal to 5, the particle moves along this direction. This is the t equal to 5. After that, the particle returns with 0 initial velocity. Therefore, distance traveled by the particle at t equal to, this is the 8 second. So distance travel in 5 second plus distance travel is 8 minus 5, that is, this is the 3 second. So look at this here, distance d equal to, this is the, this is the 10 into 5 minus 5 square plus this is the half into a means, look at this, acceleration is equal to, look at this is the 2. So look at this is the 2 into, this is the, this is the 8 minus 5 whole square. So look at this here, 50 minus 25. So this is the 25 plus this is, this cancel out. So this is the 9. Therefore 34 centimeter is the distance traveled by the particle at t equal to 8 seconds. Now we have to plot the approximate, the ST graph, that is the displacement time graph. So look at this, the displacement time graph of the particle. Look at this is the S and this is the T. So this is the, look at this is the displacement time graph. This is the T equal to 10 second and this is the maximum displacement. This is the T equal to 5 second. Okay, understood? Now question number 22. The velocity of a particle moving in the positive direction of x-axis varies as v equal to alpha root under x. Here alpha is positive constant, assuming at the moment t equal to 0, the particle is located at x equals to 0. So boundary condition of the particle, when t equal to 0, x is also 0. Find time dependence of velocity and acceleration of the particle. Now look at this here, v. Now look at this here, v equals to, this is the alpha into root under x. So here v square is equal to, this is the alpha square x. Therefore, differentiating with respect to x, we get, this is the ddx of, this is the v square equals to, this is the alpha square x. Therefore, 2v, this is the dv by dx, this is equal to alpha square into 1. Therefore, look at this, this is the acceleration. Therefore, 2 into acceleration equal to alpha square. Therefore, a equals to alpha square by 2. So, acceleration of the particle is constant. So, velocity of the particle in time t, this is the 0 plus at. Therefore, this is the alpha square t by 2. And this is the displacement. Displacement is equal to, this is the half into acceleration. This is the alpha square by 2 into t square. So here s equals to, this is the 1 by 4 alpha square t square. Okay. So time dependence of velocity. This is the, okay, alpha square t by 2, and time dependence of displacement. This is the half alpha square into t square. Okay. The mean velocity of the particle average over the time of the particle that takes to cover the s meter of the particle. Now time taken by the particle to cover the s meter. Look at this. This is the t square equal to, this is the 4s by alpha square. Therefore t equals to, look at this. This is the 2 into root under s by alpha. No problem. Therefore here s is the, this is the 1 by 4 alpha square t square. Therefore mean velocity, this is the, this equal to s by t. So this is the 1 by 4 alpha square t. Now put the value of t here. Therefore this is the 1 by 4 alpha square. T is the 2 into root under s by alpha. So look at this. This is the 1 by 2 alpha into root s is the mean velocity. Okay. Now question number 23. A point moves rectilinearly with deceleration whose modulus depends on the velocity v of the particle as acceleration equal to alpha root over v. So look at this here deceleration. This is the v dv by ds. Look at this v dv by ds. This is equal to this is the a root over v. Okay. Therefore, look at this. This is the root over v. This is the dv equal to a into ds. Okay. Now we have to calculate distance traveled by the particle when velocity is 0. So look at this integrating here v to the power half. This is the dv, it is a into ds. Now integrating. Now what is the boundary condition? Look at this when distance, look at this when distance travel 0, velocity of the particle is v naught. When distance travel s, the particle stops, that is velocity of the particle is 0. So look at this here v to the power 3 by 2 divided by 3 by 2, this equal to, look at this is the v0 and this is the v naught. Look at this here, there is a negative sign, there is a negative sign. So look at this is the a into this is the s. Look at this is the s0. Therefore, look at this here negative sign of this is the v naught to the power 3 by 2 into this is the 2 by 3. This equals to a into s. Negative sign, this and this cancel out. So distance traveled by the particle, look at this is the 2 by 3 into this is the v naught to the power 3 by 2 by a. Okay. So this is the distance traveled by the particle before coming to rest. No problem. Now we have to calculate the time at which velocity of the particle is 0. Look at this here, deceleration is equal to dv by dt. So dv by dt, this equals to a, this is the v to the power half. Therefore, look at this here, v to the power minus half dv, this is equal to a dt. Now integrating. Look at this here, v to the power minus half, this is the dv equal to a integration dt. Look at this, when t equal to 0, initial velocity v naught. When t equal to t, the velocity of the particle is 0. So look at this here, integration v to the power minus half plus 1, and this is the minus half plus 1. This equal, now limit is the, look at this v naught to 0, and this is the, look at this here, there is a negative sign. So look at this is the minus, this is the a t, look at this is the t into 0. So look at this here, this is the negative sign of, this is the 2 into v naught to the power half, this equal to, this is the a, this is the t. Now this and this cancel out, therefore t equal to, this is the 2 root over v naught by a is the time at which the velocity of the particle becomes 0. Okay. Now question number 24. A radius vector of a point A relative to the origin varies with time t as r equal to ati cap minus b t square j cap. So look at this here, r vector is equal to ati cap minus bt square j cap. Okay. Where a and b are positive constant, I and j are the unit vectors of the x and y axis. Find equation of trajectory y x. So look at this, in a plane r vector is equal to, this is the x I cap plus y j cap. This equal to, this is the at I cap minus b t square j cap. So to find trajectory, we have to eliminate t from these two equations. Here t equal to, this is the x by a. Therefore y equal to, this is the minus b, and this is the t square, that is x by a whole square. So y equal to minus b x square by a square, is the trajectory of the moving point. So obviously the equation of the trajectory is a parabola. Look at this. This is the parabola. This is the x-axis, x dash, y dash. Okay. So parabola like this. The time dependence of velocity v and acceleration w vector as well as the moduli of these quantities. So look at this here, v vector. This is the dr vector by dt. So look at this here, 2. So look at this here, a into 1 into I cap minus, look at this is the 2b into t into j cap. So modulus of this vector, look at this here, b equal to, this is the root under of, look at this, root under of a square plus 4b square t square. Okay, no problem. Now acceleration, look at this acceleration w vector, this is the dv vector by dt. So look at this here, 0 minus, this is the 2b j cap. So magnitude of acceleration, this is the 2b. Okay, no problem. The time dependence of the angle between the vector w and v. Okay. So look at this here, cos theta, this equal to, this is the w vector dot v vector by modulus of w into modulus of, okay. This is the a I cap minus 2bt j cap dot, this is the w is the w is the minus 2b j cap, okay, divide by, look at this is the root under of, this is the a square plus 4b square t square into, this is the 2b, okay. So look at this and this cancel out. The mean velocity vector average over the first t second of motion and moduli of this vector. So look at this, the mean velocity, this is the, look at this is the r vector by t. So look at this is the a I cap minus bt j cap is the mean velocity. So magnitude of this mean velocity, look at this is the, look at this is the a square plus, this is the b square t square. Okay, understood? Many thanks for watching this video. This video will be extremely helpful for your preparation in NEET, MET and advanced. Okay.